Hello, Marvels. I am back with number 7 from your homework today, over the weekend. And I'm choosing to do this problem because it's a little challenging. And it really is a secret quadratic. So some of you might be saying, quadratic? What do you mean? There's no square term in there. And I agree, there's no square term yet. But in just a little bit, you're going to see what I mean. So when I see a problem like this, one of the first things that catches my eye is that I have two competing different functions here. I have cosine of x and secant of x. And when we've had two different functions in the past, sometimes we've factored one out. And that's not actually going to work in this case. But what I can do right from the get-go is actually rewrite secant of x in a different way. So I'm going to write this as 2 cosine of x plus 1 equal to 1 over cosine of x. And maybe you also got that far when you were trying it on your own. Now I have a fraction on the right, and I do not have a fraction on the left yet, but I can make this entire thing into a fraction if I just put it over 1. And at this point, I can do a cross multiply in order to get to a place where I can begin to really do some math. So I'm going to have cosine of x times 2 cosine of x plus 1 equal to 1 times 1 is just 1. Now at this point you kind of have to treat cosine of x like you are distributing it in as a regular number. So I'm going to multiply cosine of x to each term in the second binomial. And I'll get 2 cosine squared of x plus cosine of x equals 1. At this point I'm going to substitute in. And if you wanted to substitute it in one step before, that would have been okay. But I'm going to do it now. So I'm going to say let g equal the cosine of x. And so now I have 2g squared plus g equals 1. And now here, it's a lot easier to see that this is actually a quadratic. I'm going to subtract 1 from each side so I can be equal to 0. And I have 2g squared plus g minus 1 equals 0. Sadly, this is not an example that has an a term of 1, so I have to either do master product or xbox, and I will just quickly take care of business here. And when I go to the box, then I will have 2g squared, negative 1, 2g, and negative 1g. And once you have all those values inside the square, you can begin to get the values around the outside of the square. And if you give me a moment, I will take care of that as well. So what this really looks like to me is 2g minus 1 times g plus 1 equals 0. This is not just a simple average everyday quadratic though, it's actually a trig function equation. So now I'm going to substitute cosine of x back in for the g's and let them take their places again. So it looks like 2 cosine of x minus 1 times cosine of x plus 1 equals 0. This is a multiplication problem, so I know that in order for a multiplication problem to be equal to 0, either factor 1 has to equal 0 or factor 2 has to equal 0. Let me work on that part of it now. So I'm going to have the cosine of x is equal to 1/2. In order to figure out what that equals, I can look at my unit circle and see where I have an x value that is positive. I know that that happens at quadrants 1 and 4. So where cosine is 1/2, x equals pi over 3 or 5 pi over 3. Okay, now for the second half, where cosine of x plus 1 is equal to 0, my first step is to subtract 1. So where do I have cosine of x equal to -1? Well, that only happens one time. Cosine of x is equal to -1 at when x is equal to pi. Okay, so I initially have 3 solutions. Now I check my domain restriction, and it is from -2 pi to 2 pi. So just a quick sketch of that shows that it would be like this. And I've already given the answers. I've already given a few of the answers, so I already gave this as a solution, and I already gave these two as solutions. This would be where cosine is equal to 1/2, and this is where cosine is equal to -1. But I also have 3 more on the other side, so I can find those by utilizing the fact that they are exactly 1 period away. So the other terms here are going to be -5 pi over 3 when I subtract 2 pi. And when I subtract 2 pi from here, I'll be -pi over 3. And when I subtract 2 pi from here, it's going to be -pi. So these are the 6 solutions to problem number 7. If you would like any further information, please just add that in the comment box. Don't forget to like and subscribe. I will see you on Monday.